Alrighty, and good morning, everybody. Welcome back. I hope that you guys had a good beginning of your week and that your 4-day weekend was restful and enjoyable. Good morning, good morning. And that you didn't have to spend it working, or at least not all of it working or doing homework and such and things. So, welcome back. It's nice to see you all again. All right, so to start, I just want to pop over to Canvas and go over a couple of things that are in Canvas and things that I want you guys to be aware of, and then we'll get into our lesson for today. So I need to share my screen. All right, so here's our course. Hopefully you're familiar with it now. This is what it should look like to you guys on the student side. So a few things. Obviously, we've got our calendar and modules here on the home page. I'm going to look at the large view of the calendar here. Looking at February, right? We're halfway through, essentially, and now we have this week and next week left in February. And the grading period, the last day of the grading period is tomorrow. If you have not yet submitted the assessments for Chapter 6, right, the first chapter we did this semester, I've put in placeholder grades showing that you haven't turned it in. So on the free response question self-assessment, if it has not been submitted, I've put that in as a 1. For now, it should still show up as missing for you if you haven't submitted it. But you've been in class, you've submitted things, I'm putting it as a 1. All right. So the multiple choice, if you haven't submitted that yet, the placeholder grade is a 0. Again, those are placeholders to show what your grade will be if they are not done. Once they are completed, those will be replaced with whatever grade you get for those. There's no penalty for it being late, but I do need you to know that they need to get done. So a placeholder grade has been put in there so that your overall grade is unfortunately affected. Hopefully that makes sense. Go. So there's that. So if your grade suddenly dropped, that could be why. Please take a look at your overall grades in the class, and if you're missing those assignments, that could be a reason why your grade is not what you think it might, or it should be, or it was. So please keep that in mind. And submit those things if they're not done, if you want your grade to look better on the progress report. Today, the 18th, we will be starting Chapter 8. Right, that's where we are right here. We're starting with 8.1 with confidence intervals. We'll have a presentation and we'll record the class and all that fun stuff. And then tomorrow we will have practice with these new concepts. We will then continue in Chapter 8 next week. And then if things go as I want, Chapter 9 will be the 2 weeks after that. And then the week and a half before spring break, right, the last week and a half that we will be in school in March, I've got designated as review. I'm hoping to use that time in class, right, the 3 class meetings that we have, to kind of look back at all of the things that we've covered so far in the course, right, look at example problems, practice problems. I'm going to consider, although I'm not quite sure if I'll do like some sort of practice AP exam in that time. But it will be all for review, to look back at everything we've learned so far. When we come back from spring break, we will resume with Chapter 10. Right, we'll have Chapters 10, 11, 3, and 12 left to do. So that's kind of the idea for the rest of the semester as far as the pacing is concerned, but more specifically the next month or so. And what's on the docket. right? So there's that. We're gonna look at our modules, right? Hopefully you're done with everything in chapter 6. Right? It will show you right here in the modules if you've submitted items, right? You'll get a little check mark if it's been submitted and completed. Right? So like on my test student here, test student has completed the chapter 7 math multiple choice, but not the free response questions. So this shows a little empty circle. It must submit the assignment, just showing that it's not done yet. Right, so you can look at the modules to get an idea if you're missing things, and it'll tell you which things you're missing as far as the required assignments that you need to do outside of class time. Also, please take advantage of going back into the assignments you've already submitted, especially if you don't like the score that you got. The multiple choice, when you go back into the assignment, you can look at your previous attempts. It will show you the answer you selected, along with any included feedback. All the multiple choice questions have included feedback for the choices you make. So if you get it right, awesome, cool, this is correct. It gives you an explanation as to why it's correct. You get a question wrong, it also tells you why it's wrong. All right, so you can hopefully go back and then try the quiz again and get that question correct. Right, so there is feedback on the multiple choice to help you retake it so that you can get more points if you like. Remember, you have unlimited attempts on multiple choice assessments. If you don't like your score, you don't do well the first time, look back at your responses, take some notes, do it again. All right, so please keep that in mind. On the free response questions, go back into the assessment itself from the module so you can look at your attempts, right? You can start a new attempt right here if you want or if you need to. This shows here, right? I'm looking at attempt 1. It's been submitted and graded. If I go down, it shows the submission. If you submitted a picture or uploaded a file, right, it will show up here. Depending on when you submitted this and how I was grading that day, if I was grading and providing feedback using my iPad, I'm able to write right on your document. You might have feedback written on your document. To see that, you need to look at the document here. It will not show up as feedback. It won't show this if you look at your feedback in the grades area of Canvas. Okay. So you might see feedback in here. If your feedback was provided in comments, you'll see those here, right? Go to the comments page or section. It'll give any written comments. Okay, you can also submit a comment back. So like if you've made corrections, you want me to be aware of it, you can type that in the comments here and it'll give me a message through Canvas. You can also see where you were placed on the rubric based on your work. Okay, so take advantage of this as a resource, right? If your self-assessed grade on a self-assessment was not approved, I will have told you why. I'll tell you what parts you got correct and incorrect on the free response questions. So you can go and make revisions if you want to improve that grade or at least move it back up to what you self-assessed at. All right. And when you do that, you'll go up here to a new attempt and you only need to resubmit things that you're revising. There's no reason for you to redo the stuff you already were successful on. Just do a new attempt. I'll have access to all the previous attempts, so all of your work will be saved, and just submit the things that you're correcting if you're choosing to do that. You don't have to make corrections if you don't want to. But again, make sure you're taking advantage of this if you're trying to improve your grade. Is there any questions about grades, grading, revisions, or pacing? Anything that I've talked about so far?
Is the chapter 7 assessment and the FRQ going to this week's grade?
It will not be part of this progress report, no. unless you turn it in, then I'll grade it for this progress report. But if you have not, it's not going to count against your grade. I try to put due dates so that things show up in the order that they should be done when you look at like the grade book and things like that, and the assignment list and things, because it sorts by due dates. Any other questions or anything else I can clarify? Okay. All right. Lastly, there are some new resources available that I was made aware of last week. I kind of dropped the ball on getting this information to you guys quickly, but it's here now. If you're not aware of NIMSY, or if you are aware of NIMSY, this is a reminder that NIMSY is a support for us in AP classes. This announcement that should be at the top of the Canvas page has all the information for it. So NIMSY is the National Math and Science Initiative, and has resources through a site called Blackboard, which is basically like Canvas, but it's a different service, a different provider. The resources include live virtual study and review sessions, as well as self-paced opportunities. Typically in years past, before the pandemic, there would be NIMSY study sessions that would come to the school sites in our school district and provide opportunities over the weekends for students to come and get review sessions and study sessions and practice tests and things like that. That's all being done virtually through Blackboard. If you're an OG or EHS student, you should have gotten an email from NIMSY, right, from this email, nms@geniuses.com, with your Blackboard login credentials. There's a video on how to register for the different pathways, live or self-paced. There's apps here. They're actually linked in the message if you want to go to the App Store and download the Apple or Google Play app. You just got to click the links here. San Pasqual students, you can also access NIMSY, but you need to self-register. It's not a service that your school site has put together for you like the school sites at OG and EHS have, but you still have access to it if it's something you'd like to access. You just need to follow these directions to self-enroll. There's a few other like links in here. There's a registration infographic here. It kind of shows you how to go through the registration for NIMSY here on Blackboard. We have the live session calendar. We missed the first couple weeks of it, but we can pick up on week 3. There's topics being reviewed all these days, and the topic list is here. 1, 2, 3, there we go. And we would just go to the AP stats. So this tells us the topics of those weeks. If you're planning to attend the live sessions are also going to be recorded, so you should be able to access those later if that's something you want to do. All right. And so again, I recommend kind of perusing through this if you're looking for another resource and something else that has things that could help you prepare for the AP exam that is specifically from AP teachers, scorers, and writers of the AP exams, which is pretty good resources. This is something you might want to look into. And if you have any questions, please let me know. I can find things out for you. Any questions about the NIMSY supports? Then we're going to get started with our lesson for today. Right, so stop sharing that one. This one. All right, so please have anything you take notes on ready. So I'm going to try to see if I can work this presentation in a different way. Ooh. Let's see how this works. Ooh, excellent. All right, so hopefully you guys can see the presentation here, if I've done things properly. If you cannot see it, please tell me. I'm trying a different way of presenting this today, so hopefully it works. All right, well then, we're gonna get started. All right, cool. So, Chapter 8, we're starting today, Estimating with Confidence. Section 8.1 is confidence intervals, just the basics. The next two sections we'll talk about specific confidence intervals dealing with population means and population proportions, similar to the way that Chapter 7 was broken into those two separate things to look at. All right. Confidence intervals. All right, here's what we're hoping to learn today. All right, we need to be able to determine the point estimate and margin of error from a confidence interval. Right, interpret a confidence interval in context and interpret a confidence level in context. We want to be able to describe how the sample size and confidence level affect the length of a confidence interval. Explain how practical issues like non-response, undercoverage, and response bias can affect the interpretation of a confidence interval. Right, these are things we'd like to do. All right, so here we go. So we're going to do this. I'm going to look at how this activity would play out. We're not going to have time to do this in class. So we have this mystery mean activity. All right, so suppose your teacher, me, Mr. Mosley, has selected a mystery mean value mu and stored it as m on my calculator. All right, your task would be to work together with a group of students to estimate the value of m. The following command was executed in my calculator. We used mean, parentheses, rand norm, m 2016, and we got this result. Right, the result was 240.79. This tells the calculator to choose an SRS of 16 observations from a normal population with mean m and standard deviation 20. The resulting sample mean of those 16 values was 240.79. Right. The goal would be for your group to determine an interval of reasonable values for the population mean mu. Use the result above and what you learned about sampling distributions in the previous chapter. All right. We're going to look at a possible way to kind of consider how to make an educated guess of reasonable values. Right. So we're going to go to this screen. So here's one possible way that, this is my scratch work on how we could use what we learned in Chapter 7 to come up with a reasonable range for the possible values of m. Right, so we have m is, we don't know. We went through this function in the calculator. We know that n, the sample size, is 16. We don't know mu, that's m. Sigma, the standard deviation, was 20. And we have a sample mean x bar of 240.79. Because the best thing we can do is kind of assume that this is an unbiased estimator of mu. So we use this as the estimator. We can determine the standard deviation of the sampling distribution of the sample means, right? Standard deviation of x bar, to be 5 by using our formula from Chapter 7 for that value of standard deviation of the population divided by the square root of the sample size. We get 20 over square root of 16, 20 over 4, 5. In this scenario, we don't need to consider the negative square root, right? The negative value of the square root of 16, because we're just dealing with distance. Right? And then I do 5 times 3 equals 15, because I know that within 3 standard deviations of any mean in a normal distribution, that almost all of my area is there. All my observations should lie in there, 99.7 of that, 99.7% based on our 68, 95, 99.7 rule. So I'm like, okay, well, most of my data should be in there. That should give me a reasonable range. So we get 15. 240.79 plus 15 gives me 255.79 as an upper bound. 240.79 minus 15 gives me a lower bound of 225.79. So I'm saying the interval of reasonable values for population mean mu is the interval notation, which looks like a coordinate, but this is interval notation from 225.79 to 255.79. So this is how we can use what we've learned about population means from chapter 7 to come up with an idea of a possible range of values for M in this example. Is there any questions or anything I can clarify about this example? Then we're going to jump back to our presentation here. All right. So, and move a little farther forward. There we go. All right. If you had to give one number to estimate an unknown population parameter, what would it be? If you're estimating a population mean, mu, you would probably use x bar, which is what we did in the previous example. If you're estimating a population proportion, p, you might use p hat, right, the sample proportion. In both cases, you would be providing a point estimate of the parameter of interest, right? So in this context, when we're dealing with confidence intervals, rather than calling x bar or p hat a estimator, an unbiased estimator, we're calling it a point estimate. Still an estimate. We're just renaming it as a point estimate. Okay. A point estimator is a statistic that provides an estimate of a population parameter. The value of that statistic from a sample is called a point estimate. So in our previous example, the point estimator was the sample mean, x bar. The point estimate was 240.79, the value of x bar. All right. We learned in chapter 7 that an ideal point estimator will have no bias and low variability, called it an unbiased estimator. Since variability is almost always present when calculating statistics from different samples, we must extend our thinking about estimating parameters to include an acknowledgement that repeated sampling could yield different results. This is why we end up with a range of possibilities for the parameter, right? Because each sampling will give us a different point estimate. So to account for that, we get a range of values rather than a specific value. You say, well, I think this is the one. We say, well, it could be in this range. It's somewhere in here, right? And what we're learning in this chapter is now we can, with a certain degree of confidence, say it's going to be in this range. Do we have any questions or need a moment to write anything down? So recalling our activity, right, is the value of the population mean exactly 240.79, the estimate? Probably not. However, since the sample mean is 240.79, we could guess that mu is somewhere around that value. How close is mu likely to be? Right? What's the reasonable range? Right, to answer this, we ask another question. how would the sample mean X bar vary if we took many SRSs of size 16 from the population? Which this is essentially what we did in the last chapter, right? We get a distribution for the sample means, right? So now we're back in chapter 7. We start with our parent population. We take a bunch of different simple random samples of size n equaling 16. We get a bunch of different X bars. We plot those into a distribution for the sampling distribution of X bar. This distribution will be less varied than the population, which will allow us to narrow down where we think mu is. Because our estimator is unbiased, the mu, or the mean of our sampling distribution, should be equal to the mean of the population. So it gives us a narrower window to look at. Okay, so this is exactly what we did in chapter 7. Okay, we just get a smaller variation. Okay. Is there anything I can clarify so far? So then to estimate the mystery mean mu, we can use X bar equaling 240.79 as a point estimate. We don't expect mu to be exactly equal to X bar, so we need to say how accurate we think our estimate is. In repeated samples, the values of X bar follow a normal distribution with mean and standard deviation 5. In this example, we don't know the exact value of the mean. We just know that it has a mean with a standard deviation. The 68, 95, 97, 99.7 rule says that in 95% of all samples of size 16, X bar will be within 10 two standard deviations of mu. And this is just because we know it's a normal distribution, right? Our rule says that within 2 standard deviations, 95% of our data lies within there. So if X bar is within 10 points of mu, then mu is within 10 points of X bar, because they should be equal if we have a good estimator. Therefore, the interval from X bar minus 10 to X bar plus 10 will capture, this is an important word to use, right? This interval, think of it as like a fence, says, okay, the mean of our population is within this fence. Right, so it captures mu in about 95% of all samples of size 16. Right, so now mu has a little bit of space to run around in, but we know it's in there somewhere. We're 95% confident it's in there somewhere. If we estimate that mu lies somewhere in the interval 230.79 to 250.79, we'd be calculating an interval using a method that captures the true mean in about 95% of all possible samples of this size. Meaning in repeated samples, 95% of those repeated samples would result in an interval, right, where we find the mean of that sample and then we do 2 standard deviations from that mean that would capture the true mean. The true mean would be somewhere in that interval. There would be some cases where we just miss. That's going to happen. Does anyone need a moment to write anything down? Okay. So we have our estimate plus or minus the margin of error. In our previous example, the margin of error was the 2 standard deviations to the left and to the right. That gives us our margin of error. A C% confidence interval gives an interval of plausible values for a parameter. This wording is important, plausible. This means it's more reasonable than possible values, right? We could, the number of possible values is much larger. It gives us values that aren't necessarily reasonable, but possible. Plausible gives us things that are much more reasonable. Like these are all things that could really happen. Right, so this gives an interval of plausible values for a parameter. The interval is calculated from the data and has the form point estimate or a statistic plus or minus the margin of error. Right, and in this case, the margin of error uses the standard deviation times how many standard deviations you want to be within the mean. The difference between the point estimate and the true parameter value will be less than the margin of error in C% of all the samples. The confidence level C gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. So again, we're using that word captures, contains, right? And so again, we have two different things here. We have a confidence interval, right? A certain percentage confidence interval, right? And that gives us an interval of plausible values for a parameter. And we can be a certain percent confident that that interval has our mean or our parameter. And a confidence level says that we are how successful our method will be in capturing the mean over and over again, right? So it could be 95% successful, meaning 95% of our samples will result in an interval that has the mean inside of it. Okay, so these are two different things that are very, very closely related, the interval and the level. Does anyone need a moment to write anything down? So the confidence level is the overall capture rate if the method is used many times. The sample mean will vary from sample to sample, but when we use the method estimate plus or minus margin of error to get an interval based on each sample, C% of these intervals capture the unknown population mean mu. So again, we see our example. We start with a population with a known standard deviation, unknown mu. We do a lot of simple random samples of the same size. We get a distribution of X bars, and we plus or minus our standard deviation, and we get a bunch of different confidence intervals. Right, 95% of these intervals capture the unknown mean mu of the population. Visually, it looks something like this. If we have our sampling distribution here, our mean, the true mean, is down the middle here, and so each horizontal line here represents a sample interval, right? The confidence interval of each sample. So like our first one was pretty darn close, right? The middle here, the red dot, represents the mean from that sample. So we can see that the first 4 samples we did all captured the true mean, right? This 5th one misses. Right? It's just this interval misses the true mean, the others all capture it, meaning nowhere in this interval exists this value. All the rest of them now hit that value again, so these ones are all good. Okay, so this represents how repeated sampling gives us all these different sets of intervals. 95% of these intervals will capture the mean because we used a 95% confidence interval. Is there anything I can clarify? So we get these two statements, right? These two things I think you should have in your notes so that you can use them in examples and have the proper verbiage in the right order when talking about these two different things. So interpreting confidence intervals. To interpret a C% confidence interval for an unknown parameter, say we are C% confident that the interval from one value to another value, lower bound to the upper bound, captures the actual value of the population parameter in context. So then you would just kind of like copy whatever is going on. So we could say captures the actual value of the population mean of student heights. I don't know, right? It would depend on your context. Interpreting confidence levels, to say that we are 95% confident is shorthand for if we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter value. The verbiage used in these statements and the order in which these things are said matters. Right? It is incorrect to say that we are 95% or there's a 95% probability that the interval captures the actual value. That's wrong. That is not what this is telling us. That's not what the interval tells us. Right? So to say there's a 95% chance or a 0.95 probability is incorrect. You will not get credit for that response. We are 95% confident that our interval captures the actual value. That's how it should be said. Right? In a confidence level, right? If we take many samples of the same size from the population, right? So we're saying over the course of lots of samples, we're not saying we're 95% sure that this particular interval captures the mean or captures the parameter. That would be incorrect, right? Over the course of all of our sampling, or if we repeated this many times, 95% of our samples would result in an interval that captures the actual parameter. The verbiage is important here. Is there anything I can clarify? Does anyone need a moment to write anything down for their notes? The confidence level tells us how likely it is that the method we are using will produce an interval that captures the population parameter if we use it many times. The confidence level does not tell us the chance that a particular confidence interval captures the population parameter. Right, so it doesn't tell us whether, like, okay, so I took a sample, we get a interval, we can say like, oh, okay, well, I'm 95% sure that this interval has the mean in it. That's not true. We're 95% confident that if I repeated this process over and over again, that about 95% of these intervals will have the mean, right? Each individual interval either has the parameter or it does not. So it's either 100% that it has it or 0% it does not. Those are the only two options if we're looking at a particular confidence interval. Instead, the confidence interval gives us a set of plausible values for the parameter. We interpret confidence levels and confidence intervals in much the same way, whether we are estimating population mean, proportion, or some other parameter. Okay. See, we need a moment to write anything down. So now, why would we choose to settle for just 95% confidence when estimating a parameter? Well, if we want a greater confidence, then we have to pay the price of having a wider interval, meaning there's more possible plausible numbers. Right? When we calculated a 95% confidence interval for the mystery mean mu, we started with the estimate plus or minus the margin of error. Right? Our estimate came from the sample statistic x bar. Since the sampling distribution of x bar is normal, about 95% of the values of x bar will lie within 2 standard deviations, right? 2 times sigma x bar of the mystery mean mu. That is, our interval could be written as 240.79 plus or minus 2 times 5, which would be x bar plus or minus 2 times sigma x bar. Right? That interval is considerably smaller than if we did 3 standard deviations. Right? That's 30%, about 1/3 larger on each side of the mean. It's a lot more possibilities, or a lot more plausible answers. It gives us more confidence. We get up to 99% confident, right? But it gives us a wider range of plausible answers. This leads to a more general formula for confidence intervals, which is the statistic, x bar, p hat, standard deviation, so on, plus or minus critical value times the standard deviation of a statistic. And the critical value is how many, essentially, standard deviations do you want to be to the left or to the right? Right, 1, 2, 1.5. It depends on the percentage of confidence that you want. So in calculating a confidence interval, the confidence interval for estimating a population parameter has this form: statistic plus or minus critical value times standard deviation of statistic. The critical value times the standard deviation is the margin of error. Where the statistic we use is the point estimator for the parameter. So we have some properties of confidence intervals, right? The margin of error is, as we said, the critical value times the standard deviation of the statistic, not of the population. The user chooses the confidence level, and the margin of error follows from this choice. Right? If I want a 95% confidence level, the critical value is 2. If I wanted a 99.7% confidence interval, the critical value is 3. If I wanted 68%, critical value would be 1. If I want something in between those, we'd have to use table A and figure out that z value. Right. Critical value depends on the confidence level and the sampling distribution of the statistic. Greater confidence requires a larger critical value, because a larger confidence percentage means we're widening our range. Right? So we need a larger critical value. The standard deviation of the statistic depends on the sample size. Remember, the larger sample size, the less variation we get, so the standard deviation gets smaller. Right? Bigger samples, smaller sample size, more variance. Larger sample size, smaller variance. Bleh. Does anyone need a moment to write anything down? Please raise your hand. So there are 2 important cautions to keep in mind when constructing and interpreting confidence intervals. 1, our method of calculation assumes that the data came from an SRS of size n from the population of interest. Right? We're assuming we're using a simple random sample. Right? There are other sampling methods that we can use that we learned about in chapter 4, right? Such as a stratified random sample or cluster sampling and things like that. This method of calculation does not involve those sampling methods. Those sampling methods require much more complicated calculations, which we're not going to cover. So this is assuming a simple random sample. The margin of error in a confidence interval covers only chance variation due to random sampling and random assignment. It does not cover possible errors due to question bias or undercoverage or non-response. Right? Other types of bias that can occur aren't covered in this type of margin of error. It only covers what would be considered like sampling bias, not response bias. Okay. Is there any questions or anything I can clarify? So then, that's the end of this presentation, right? Hopefully we are beginning to learn how to determine the point estimate and margin of error from a confidence interval, right? We're learning that we can interpret a confidence interval and confidence level in context, and there's specific verbiage for those. We can describe how the sample size and confidence level affect the length of a confidence interval, like the size or width of the interval, right? Sample size, larger sample size makes it shrink. Larger confidence level makes it expand. Right? Explain how practical issues like non-response undercoverage and response bias can affect the interpretation of a confidence interval. Right? Those are things that must be considered outside our margin of error. And we've hit the end. Right, so that is the lesson for today. Tomorrow, right, we will be doing some practice exercises and looking at some examples on how to actually apply this and use that proper verbiage and interpret confidence intervals and confidence levels and things like that. So tomorrow you're going to want to have these notes with you. There will be opportunities to work on these types of problems. Also, the practice problems for section 8.1 along with their solutions are available in Canvas, and there are some worked examples from the textbook available in the resources in Canvas as well. And the 8.1 study guide that I make is in the resources for 8.1 as well. So if you'd like to take a look at those or look at some of those practice problems, that is recommended, but not required. Other than that, that's the end of our lesson. So I will see you guys tomorrow. Have a great rest of your day. And if there's anything else I can help you with, please feel free to stick around and ask for that help. So have a wonderful day, and I'll see you tomorrow.